Hello guys, I'm Kumar K, your favorite teacher for DSA plus OA plus CP. Previously, I worked at Amazon and Mia.net. As a software engineer, I cracked those offers off campus despite being from a tier 4 college. And now I spend most of my time in guiding and training lovely students like you. So I know that many of you are recently giving, your Amazon online assessments for SD1 role, SD2 role, and even SD internship roles. And I get like 50 to 100 messages on a daily basis, to be honest, that the students are facing lots of problem in their Amazon online assessment because suddenly since last 3 4 months Amazon has started asking very difficult problems in their online assessments. Okay, they are asking, earlier they were more focused on hashing, binary search, two pointers, sorted sets, things like that, and their implementation. Sometimes, occasionally, hard questions used to come, but now all the questions, 80% of the times they are involving segment tree, Fenwick tree, and very hard level dynamic programming, right? Things like that it involves. So we need to, train for it. In this particular video, in this particular session, what I'm going to do is that recently a problem was asked. It's a very hard problem, and its efficient solution requires like segment tree and Fenwick tree. So we are going to solve this problem, and I will show you how Amazon, mainly focuses on your problem solving skills and your thinking skills. Okay, why the most of the students face problem in the OAs? Because they are just doing, standard DSA questions, 200 to 500 easy medium lead code GFG questions, influencer DSA sheets, and those things are, that they are not enough, right? You need to keep on practicing hard level DSA. You need to keep on practicing hard unseen OA problems of different companies, and you need to do competitive programming as well. Okay. So on this YouTube channel, I keep on making these high quality videos for you. So please make sure you like, share, and subscribe if you find them valuable. Okay. So yeah, the best Amazon OA roadmap. See, the best roadmap to prepare for Amazon OA in 2025. I have given everything in this document. These are my Amazon joining goodies when I got the offer from Amazon back in 2021. You guys should go through this Amazon OA roadmap 2025, okay? Because see, I've seen that no one on LinkedIn or YouTube, explains OA related stuff, or the roadmap for OAs, okay? Specifically as per the 2025 trend. But I am very active in the OA market. I keep on checking what each company is asking. That's why I have so many student selections, right? So yeah, go through them. And if you want day live training plus one-to-one mentoring and things like that, you can check this link also of my program. Recently, one of my students cracked a 51 LP off-campus SD offer from Amazon despite being from a Tier 3, Tier 4 college. Then one more student of mine, Sukriti, cracked SD intern plus full-time offer from Amazon. Like 58 students of mine have cracked, engineering offers from Amazon in 2025. So that's how strong and powerful things are when you know how to deal with OAs and interviews of fandom level. Okay. So congratulations to all of them. And yeah, one thing I wanted to say that recently one of our students, Yashasvi, has cracked SD internship offer from Google as well. Okay. And we are trying to give our students as many Google and Amazon and Microsoft referrals as possible. So if you want Fangam referrals, you can check these things. Now, guys, before I start discussing this problem, there is very important prerequisite if you are preparing for good level of DSA plus online assessments plus competitive programming. I am giving you this very important link. Please go through this link. Please complete this for 5 to 10 days. This is made for the people who are intermediate in DSA. Okay. If you are intermediate in DSA, it's totally made up for you. Okay. Now, okay. Yeah. So what I want is that you go to this website and you complete everything given here from start till the end. Okay, and trust me, it's going to help you a lot, really a lot. Just complete it. Once you have completed it, now you can watch this video, because while explaining the concepts in this video, I will be assuming that you know everything, the good, fundamentals of OA, CP, and hard level DSA very nicely, which I've taught in that prerequisite course. Okay, yeah. So today I'm feeling very good, though I'm very tired, but I have to make this video for you guys. I need to contribute. Okay, I need to make your life better, and I need to make you happy. So Guys, this is the problem. This problem was asked here. It can be seen in the Litco discuss post as well. Okay. So obviously problem is difficult. I can try to show it to you here. You are given an integer budget representing the budget of the customer, integer array cart items of length n and cart items of I, price of the ith item. For this subcart, determine the minimum number of items required to remove so that the price of the cart item does not exceed the budget. Note that the item at index I cannot be removed. Okay. So what they are trying to say? They are saying that you are given an integer array. Okay. No problem about that. At each index I, you have to consider the sum of the elements from, let's take one base indexing from index 1 to index I. Whatever the elements are there, you have to take their sum, guys. You have to take their sum. No problem in that. If the sum exceeds the budget, whatever the budget value they have given, then you have to remove minimum number of elements. You need to remove the minimum number of elements from 1 to I, so that the total sum is less than equal to the budget. That's what they're trying to tell you. Okay. That's what they're trying to tell you. So now what do we do in this case? So I will try to show you some example of 237, right? Let's take it as 237 and the budget is 8. Okay. So we always start everything with the name of God. So let's just start and let's be very quick. Ram Ram. So 237 is given to you. Talking about the budget. Budget is, let's say, 8. So if you only want to solve the for this much part of the array, what it is 2. Is 2 less than equal to 8? Yes. So you don't have to remove any number, right? That's why the answer is 0. So for this case, the answer is 0. Now for 3. For this case, you will, this is index 1, index 2, index 3. So to find the answer for index 2, you first find the sum of the numbers from 1 till I. 2 plus 3, 5. 5 is less than 8, right? 5 is less than equal to 8. So no problem. You can just afford removing nothing from here, right? Right? So hope you guys can understand that for each index I, you need to find the answer. Okay. So the final answer will have n integers. You have to solve for each index I. Okay. You need to solve it for each index I. So let's go back to the problem at hand. So this thing is clear. Now if I try to solve for index 3, for index 3 what I will have to do, I will have to consider all the elements like this 2, 3, 7. Now what is the sum of 2, 3, 7? 2 plus 3, 5 plus 7, 12. Is 12 less than equal to 8? No. Guys, 12 is not less than 8. But you have to somehow make that 12 less than equal to 8. So you need to remove some elements. Now, I want you to use the greedy mind, the greedy analogy, not greedy mind, your greedy analogy, and tell me which numbers should you try to remove from 237 so that the sum becomes less than equal to 8. Also, there is one more constraint in the problem, and that constraint is that the constraint is mainly that you cannot remove the ith element when you are trying to solve the question for the ith index. Okay, so let's go and check it out what's happening there. So 2377 cannot be removed because you're solving for this index. Okay, so I will try to remove the biggest element, right? I'll try to remove the biggest element because whatever is the biggest element in the remaining numbers. So 3 is the biggest element. Let's remove 3. Now it looks like 2 comma 7. Even though I have 2 comma 7, what is the sum of 2 comma 7? It is 9. It is still greater than 8. No, 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 no. You tried removing 3, but it is still greater than 8. So it does not work. You also need to remove 2 now. Remove 2. Now it becomes 7 and 7 is less than equal to 8. So how many elements do you have to remove? In this case, 2 elements. So the answer is 2. Okay. So hopefully by now, each one of you have understood the problem that for each index I, will get the sum of the elements from index 1 to index I, no problem in that. Then you have to remove the minimum number of elements from that sum so that the total sum becomes less than equal to budget. That's it. Now tell me, use your brain and tell me, Which elements should you remove apart from index I to make sure that the sum decreases and becomes less than equal to budget as quickly as possible? Because you have to remove minimum number of elements. The logic is simple. You will always try to remove the largest elements, because if you remove the largest elements from the sum will decrease quickly. If the sum is decreasing quickly, there are very high chances of sum becoming less than equal to budget. That's it. So this is the first, like if I write here the analysis point, analysis, always try to remove, just let me write here quickly, the largest element from set of index 1 to I except index I, that will decrease the sum very fast, and it will increase the probability that your sum becomes less than equal to budget in minimum number of removals. So, the brute force solution time complexity will be O of n square log n. So guys, what will be the brute force solution time complexity? See, in this online assessment scenarios now, when you are, let's say, not able to get the efficient approach, what should you do? You need to just write the brute force. What would be the brute force? How will you solve for an index I? For any index I, the solution is pretty simple, right? This is the array given to you, right? As we are doing OACP stuff, we want 51 lakh rupees in our bank account. So how do we solve these problems? Yeah. So whatever, if you have to solve for I, let's say you have to solve for I, what will you do? O of n log n time will be taken to sort everything from index 1 to I. If I am at I will store all these elements in another array or in another set or sorted set. So I will store all the 1 to I elements somewhere and I will sort them. Once I sort them, let's say they were 1, 2, 3, 4, 5, 6, 7, 8, something like that. Once I sort them, I have their sorted order 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now let's say my budget is 10. Budget is what? 10. So I will never remove the element which is the ith element, okay? But apart from that, whichever is the biggest element, okay, apart from I will try removing that. I will try to remove 7. In sorting it took n log n time. Now I will travel this list. I'll try to remove 7. Is the remaining sum of 1 to 6 plus 8 less than equal to budget? No. Then I'll try to remove the second largest element. Then I'll try to remove the third largest element. Then I'll try to remove the fourth largest element. If I remove 4, 5, 6, 7, now the answer will be 1 plus 2 plus 3 plus 8. Is this less than equal to 10? Is 1 plus 2 plus 3 plus 8 less than equal to 10? Think about it. Think about it. Think about it. 3, 3, 6. 6 plus 8, 14. No. So I'll try to remove 3. 1 plus 2, 3, 3, 11. Still not less than equal to 10. Now what will you do? You'll remove 2. 8 plus 1, 9. Yes, yes, yes. So, how many elements you have to remove? 1, 2, 3, 4, 5, 6. 6 elements. So, for index I, in n log n time you sort and then you travel the list in O of n time again. So, n log n plus n time you take to solve for a particular index I. This n you can ignore because n log n is much bigger than n. Okay. You should watch my time complexity and space complexity videos. In case you don't know these concepts, I will add those prerequisite links in the description for you people. Okay. So, Ram Ram. So, every ingoing and outgoing breath, always, chant the name of God Ram Ram. So you can get moksha. Okay. Now, going back to the session. So, this problem was asked here. These things are clear. Now, for each index I, it takes n log n plus n time. So, how many indices there are? I equal to 1, I equal to 2, like this, till I equal to n, right? Let's be quick. For any random index I, you are taking n log n time plus n. Plus n you can ignore, n log n time. So if you take n log n for each of them, in worst case, it is not n log n. Basically, for I equal to 1, it is n is equal to 1 only. For I equal to 2, n is equal to 2, right? So it is like 1 log 1 plus 2 log 2 plus 3 log 3 till n log n, something like that. So, you know, you log n thing you can take separate. It will come around n square log n, something like that. Okay, n square log of n square, and this n2 goes ahead, then 2n square log n, something like that. And this 2 will be, can ignore the constant. N square log n is the time complexity. So we have, figured out the brute force. Now, how to solve it efficiently? So there are many ways, there must be multiple ways to solve it efficiently, but the best direct way is use segment tree or Fenwick tree and do very deep level observations. And on the top of the segment tree, you need to put a very smart level binary search as well. That's what they have to do. So if you are my course student, 851 hour course student, many problems exactly similar to this are in our 15 to 25 hour, in our special segment tree course. Okay, the 15 to 25 hour sorted set course also we are making, I think so. But you need to watch those segmentary videos. And if you are my YouTube community student, I will add the links to basic segmentary videos of mine. I have taught segmentary in such a way you'll just fall in love with it. Trust me, trust me. Just watch that video and then you have to watch it from this part, because now I'll quickly try to breeze through the problem. I'll be skipping the implementation, I'll be skipping the some crucial details and all that, because I have to keep the video short. If the video gets too long, you guys don't watch. So let me be very fast and let's directly go to the solution. Okay, let's go to the solution now. So now let's go to the solution n square. So guys, optimization will just require your segment tree. So what are you going to do is optimization, right? You will create another array. We know that the array elements can always be like this. The array elements will always be from 1 to 10 raised to 5. Okay, 1 to 10 raised to 5, no problem. Okay, so the optimization is you will create another array b of I. It will store like b of I, or b of I should store sum of elements which are equal to I till now. Or let's say b of u equal to sum of elements which are equal to u currently. So what I'm trying to say, let's say your array A is 1 1 2 2 3. So 1 1 2 2 3, right? So the b array b1 will be 2, b2 will be 4, and b3 will be 6. Okay, if your index I on the 8th array is at the end. So what I'm trying to say is that you will store the information, you will store the frequency in a smart sum manner. Okay, because we need the sum of the elements, right? That's why. So what I'll try to do is, this is your array. So 1 comma 1 comma 2 comma 2 comma 3 comma 3. Let's say this is your index I. Okay, if this is your index I, your b array should look like this. B array is like this, right? Index 1, index 2, index 3. So this is the index I, means you're considering elements still here. So if you're considering elements still here, what you're going to do, You are just how many times one is coming? One is coming two times. So one plus one is what? Two, right? So I will just write here two. Two. Two comma two. Okay. So how many times is 2 coming? 2 times. So 2 plus 2, 4. So basically I am writing not just their frequencies but also I'm adding their sum. So 2 coming 2 times, 4. 3 is coming only one time. So 3 ones are 3. So I will just write 3. So I hope you understood the meaning of B of U. B of U will tell you the sum of all the elements which are equal to U in the array A till index I. Till index I. So for 1 to I, this is how your B array looks like, okay? But if you go to, let's say I plus 1, you go to I plus 1, what is going to happen? 3 is coming one more time. So you need to add plus 3 here and this will become 246, okay? So I hope you got all the idea. Okay, the B array has been made. Now, why are we making the B array? Why are we making the B array? What is the reason of making the B array? Why can't we just enjoy and chill? Why can't we just enjoy and chill? So even I have to think why were we making the B array, right? So hmm, okay, fine. Watch looks good, right? Anyways, so B array. Hmm. Whew. When we make the B array, it makes something very easy for us. That's the main crux of the matter. Okay. There is one crucial detail which you should always remember. The crucial detail is that when you're trying to reduce the budget, you cannot remove a of I. You cannot remove a of I. Okay. So if you're solving for index I, okay. So in your mind, let's say this is the sum from 1 to I minus 1 is sum 1. And this is 1 to I is sum 2. So you always keep track of the current sum and the previous sum. Okay. And the budget is B. Now they want for index 2 that sum 2 is less than equal to B. That's what they want, right? That's what they want, right? And let's say this element is A of I. So sum 2 is what? Sum 2 is nothing but sum 1 plus A of I less than equal to the budget B. Or budget ko, let's write the budget as, T, something like the target or something. Or let it write it as P. Sum 2 less than equal to P. So sum 1 plus A of I is less than equal to P. That's why you can just say that someone needs to be less than equal to P minus A of I. This trick you have to use, okay? Basically, ये trick आपको हमेशा use करनी है. Whenever you're trying to solve for 1 to I, forget the equations. Only just try to find out the previous sum from 1 to I minus 1. So the previous sum from 1 to I minus 1 is this. So only the previous sum needs to be less than equal to P minus A of I. P is already known. Given in the question, AI is also known. So you will only maintain the elements from 1 to I minus 1. You will only maintain the elements from 1 to I minus 1 in your B array when you are trying to solve for index I. This is the most important statement. You will only, you will only maintain the sum and the data of the elements from index 1 to I minus 1 when you're trying to solve for index I. Use that equation, okay? Okay, guys, I love you. I really love you. I love you more than anything, okay? Obviously, God comes first than you guys. So, God, family, students, most important. So, what were we doing? Okay. So, let me write here. When trying to solve for index I, keep track of data and sum of 1 to I minus 1 in the B array. That's it. Now, how will you solve it when you have every data in the B array? The nice thing about the B array is that it keeps the thing sorted. It keeps the thing sorted. Because B array index is going from 1 till 10 raised to 5, right? So B1, B2, B3. I hope you understand, guys. The main difference is that the B array keeps the things sorted, right? B array keeps things sorted. So let's go here and let's see how can we take the advantage of the sorted B array. Okay. This B array is nothing but our segment tree. Okay. The B array is nothing but our segment tree. For segment tree, you need to watch our videos. I have created a segment tree on the top of the B array. Okay. So now listen up. Listen up. Listen to me very carefully now. Okay. Listen to me very, very carefully. As carefully as you can. So let's think. The problem is so hard that even I have to think what to tell you. So let's think. Let's cook, boys. Let's cook. And girls, let's start enjoying. Same goes for the boys also. Let's enjoy. So if you have the B arena, it makes your life pretty easy actually. One, one, two, two, three, three. Okay, right? Let's say things like this are there. Okay, hmm. And let's say you're trying to solve for index I, and this is your I minus one. Okay, okay, sir, no problem. One, two, three, four, five. Like this, you have things. You convert it to B array. In B array, the index 1 is saying what? 2. The index 2 is saying 2 plus 2, 4. Index 3 is saying 6. And the other indices will say 0, right? 0, 0, 0, 0, 0. Why? Because the data of 1 to I minus 1 only has the numbers from 1 to 3. Okay. So they only have the numbers from 1 to 3. Okay. So this data has been stored here. Let's say your budget, whatever budget, now what you were doing, budget minus something, right? Yeah, this budget minus a of I. Okay, this thing should be greater than equal to this sum, right? So let's say budget minus a of I is let's say it is 2. Okay, it is 2. Okay, so now what will you do? Let's say you write the last limit as 6. In actual question, the last limit you should set to 10 raised to 5. Okay. Why? Because the largest element in the array will be as large as 10 raised to 5, right? That's why. So, the largest limit 10 raised to 5. But here, let's set it to 6. So, what will you do? You will do one special query on this array. You will ask for sum of all the numbers from 1 to 6. What is the sum of all the numbers from 1 to 6? The sum of all the numbers from 1 to 6. This query will be answered in O of log n using segment tree, by the way. Okay. So the sum of all the numbers from 1 to 6 is what? 6, 4, 10, 12. Is this 12 less than the budget minus A of I? No. No, it is not. See, you will make the first query. Is the sum from 1 to 6 less than equal to 12? Sorry, less than equal to 2? No. So now the second query will try to decrease that window. Now you will try to query the sum from 1 to 5. Why? Because 6 must be the largest element, right? 6 must be the largest element. See, if you have done query from 1 to 6 and the sum is coming greater than 2. तुम ही सोचो 1 से 6 तक के जो सॉर्टेड नंबर्स यहाँ पर मैंने लिए उनका सम 2 से ज्यादा आ रहा है तो मैं कौन सा एलिमेंट निकालूंगा I'll try to remove all the occurrences of 6, not the largest element. If I remove the largest element, the sum decreases fast. I taught you in the brute force also, baby. So now, if this did not work, I will do the second query quickly. The query will be what is the sum in this array is getting updated regularly, by the way. When you go to I plus 1, you again have to update the array. So you cannot do prefix some pre-calculation to answer the sum of the range 1 to I in O of 1 time. You need O of log n time using segment tree. Okay. So now you will do the query of sum of 1 to 5. What is sum of 1 to 5? 12. It's also not working. So now you will do query of the sum of 1 to 4. That is also 12, not working. Now the next query you will do is the query of the sum from 1 to 3. That is also 12, not working. Now you will do the query of the sum from 1 to 2. What it is? 6. Guys, you kept on shrinking the window, and now finally when you reach at index 2, the sum from 1 to 2, it has decreased the sum from 12 to 6. But is 6 valid? Even 6 is not valid. Why? Because our budget minus AI is 2, we need to become less than equal to 2. So even this failed. So now I will do the query of sum of 1 to 1. 1 to 1 mentoring. Students like 1 to 1 mentoring with me, right? So the sum from 1 to 1 is what? It is just 2, man. And this 2 is less than equal to this 2. So guys, you have found out that these elements are valid. Rest all you need to remove. So whatever are the elements from 2 to 6, by maintaining one more array, or just by maintaining one more frequency array and a segment tree, you can just know how many numbers are there from 2 to 6. Okay. Like you made this array, na, you can make a frequency array also. 1, 2, 3, 4, 5, 6. The frequency of 1 is 2, frequency of 2 is 2, frequency of 3 is 2, frequency of 4, 5, 6 is 0. So in this frequency array, you come to know that only 1 to 1 is valid. It means everything from 2 to 6 is not valid. So how many elements are there from 2 to 6? Is nothing but the sum of this array from index 2 to index 6. 2 plus 2, 4. So basically you need to remove 4 elements. So guys, you have solved the problem again for each index in n log n time. In how much time? N log n time. How? Why n log n? Because this is index I, right? And this is index I minus 1. Okay. For this, you have made another B array also from 1 till 10 raised to 5, right? You have made a frequency array also. Let's call the frequency array C array from 1 till 10 raised to 5. You guys know what these arrays do, right? Store the frequency of the elements from 1 to I minus 1 and also the sum of all the elements equal to them. Okay. Now you always do the first query, which is sum of the numbers from 1 to 10 raised to 5. What is the sum of the numbers from 1 to 10 raised to 5 which are coming from 1 to I minus 1? Okay. If this sum is not working, you try for smaller sums. So in the worst case, first you will try for query from 1 to 10 raised to 5, then 1 to 10 raised to 5 minus 1, then till 1 to 1. So it took 10 raised to 5 operations per index, right? And also the query is taking log n time. So total n log n, right? 10 raised to 5 log n. Okay. But guys, you can just do a brilliant binary search as well now. Why can you do a brilliant binary search? I will explain these things in even more detail in the part 2. But for now, I have to keep the video short. Brilliant binary search can be done. Why? If you know that the sum from 1 to 10 raised to 5, let's say your budget minus a of I is equal to 10. Okay. So you know that sum from 1 to 10 raised to 5 is, let's say, coming as 1000 or 100. Now rather than trying for sum from 1 to 10 raised to 5 minus 1, you will instead try sum for 1 to 10 raised to 5 by 2. This is the lower limit. This is the lower limit. This is the higher limit. Low plus high by 2. You will do a binary search. You will try with this sum. If this sum also comes less than equal to the budget, then you go again half like that. Okay. But if the budget comes less than equal to as you need it, then you can try on the right hand side. I hope you guys get the binary search logic कि हम लोग पहले क्या कर रहे थे? We're checking, is the sum 1 to 10 less than equal to budget? No. Now check 1 to 9. It is also not valid. Check 1 to 8. Not valid. Check 1 to 7. 1 to 6. 1 to 5. 1 to 4. 1 to 3. 1 to 2. 1 to 1. But the nice thing is that all the array elements are positive. So once you know that the budget from 1 to 10 is not working, it's not working, it's really not working, then what you should do is you should directly check from 1 to 5, which is the middle. Binary search, the low, high, middle. If that is also not working, then try the mid of 1 and 5 too. Okay. And let's say for 1 to 10 was not working, but for 1 to 5, yes, it is coming less than equal to the budget. Then now you need to try on the middle of the right range, because you might be able to increase the window and still get less than equal to budget. We need to find the largest valid window. Okay. So if you have not done binary search course, please do my binary search prerequisite course. It's totally free. So many things are free for you, man. And I'm going to make a detailed part 2 also as well, and I'll just add the recording in the link. So please make sure you let me know in the comments if you want it. So if you do like that, your each query gets solved in log n cross log n time, in log n square time. So you have to make two segment trees. One is for the frequency array and one is for this B of u. Okay. And guys, one last crucial thing I did not explain is that, yeah, this, I told you, I will not always go in very much depth in the short videos, but still let me do it for you. See, let's say this is 1 and this is limit. Okay. And let's say here it is written as 20, and let's say your limit was 10. Okay. So you know that sum of 1 to 10 is not working. It is coming greater than budget minus a of I. Okay. This is, let's say, yeah. Okay. This is the data of all the elements from 1 to I minus 1, right? They have been stored A array converted to B, right? You can just say B. So now what? Well, now if this is not working, that you, in general, if you do linear search, you have to try from 1 to 9, right? The limit is 10. But before trying from 1 to 9, you should know that this 20 means that 2 times 10 is coming. So you should check what happens when you only see, when you take 2 times 10, what is happening you already know, because the sum is involving 20. But what will happen if you just remove 110? Things might start working. So before you decide that this is not working, now let's say you say that, sir, sum from 1 to limit is not working. I would ask you, please check what is the frequency of that number limit. If you make its frequency 1, is it still working? Yes. Then you need to use some basic mathematical formulas and need to find out what exact frequency you can keep of that limit so that the total sum is less than equal to budget. So hopefully you guys liked it. Okay. Ram Ram. Ram Ram. Really love all of you. Now, so you can always use some mathematics, right? You can always use some mathematics for that.